Okay, hi guys. We are going to go through some review for the test tomorrow. Unfortunately, my computer at home wasn't working and neither is the computer at school. So we are doing this on my phone. So bear with me if it's a little bit small. So the big thing that I want you to know for the test is that when we talk about derivative, we're talking about the idea of slope, right? And so, yes, you need to know all those derivative rules, but at the end of the day, this is going to boil back down to being slope. So if you've got something like this where it said, what can you say about the derivative at these points, I would really be asking, what can you say about the slope at these points? So at x equals -1, this has a negative slope, because your slope there is negative, right? The slope of the tangent line is negative. At 0, that's a turning point. That has a 0 slope. Slope of the tangent line is 0. And at 2, slope of your tangent line is positive. So this would have a positive slope. So again, anytime we're talking about derivative, we're talking about slope. Similarly on this one, so shown above, we have the tangent line to the graph at 2. What's the value of f prime at 2? Remember that the derivative is the slope of the tangent line. So the slope of that is up 1 over 2. So my slope is 1/2, which means my derivative is 1/2. So then we got into the limit definition of the derivative, and this is where we want to make sure that we know your labels for this graph. Whoops, opening my email, sorry. So this is x, this is x plus h, because the distance between your x values is h. And then these are your y values, so this would be f of x, and this would be f of x plus h, right? So then from there, we can actually use the limit definition. So the big thing on this is make sure you're actually using a limit. So I know this is one of my y values. My other y value is f of x plus h, because those are my inputs. And that's going to be square root of x plus h plus 4 here. So the slope between those would be the change in y over the change in x, which is just h. And then we're taking the limit as h approaches 0. So really, as the size of that interval gets infinitely small. So from there, we can try direct sub. We wind up with 0 over 0, which is indeterminate. So I'm going to multiply by the conjugate. And I don't have a ton of room here because we're on my phone. So I'm just going to do that in my head. So multiplying through by this numerator, but with the sign in the middle changed to a plus. So that's going to be x plus h plus 4 minus x plus 4, which when you distribute that out will give you minus x minus 4, all over h times the conjugate. So one radical plus the other. In your numerator, the x squareds the x's will cancel and the 4's will cancel. So you're just left with h, and that h in the numerator cancels with the h in the denominator, so you're just left with 1. And when you plug in 1 for h, you're going to wind up with 1 over x plus 8, or plus 4, plus square root of x plus 4, which you could write as 1 over 2 square root of x plus 4. Now, from there, pretty much everything else we did were just derivative rules. So we're going to start with a couple from the table to make sure we know the rules. And then from there, we'll move to using actual functions. So when I look at this first one, I see it's h of f over g. F over g is a quotient, and so I'm going to use quotient rule. So this is going to be low d high minus high d low, square the bottom, and away we go. And then we're just going to plug in values from our chart. So we're looking at when x is 3, so I'm looking at these values. So g is 2, f prime is -1, f is 1, g prime is 1, all over g squared, which would be 2 squared. So this is going to be -2 minus 1, so -3 over 4. For the next one, now we have a different structure. So now this is a product. So for a product, you're going to take your first part and your second part, do derivative of the first, leave the second alone, plus derivative of the second, leave the first alone. And then we're going to plug in, again, 3. So I'm looking at 3. So f prime is 2, g is 1, plus g prime is -2, and f, I believe, was 3. So that's 2 plus negative 6, so this is negative 4. So this really looks at if you know the rules. So for the next one, we are finding C prime when C is f to the second. So that's chain rule. I see that my inside is f, my outside is squared. So if I make u f of x, and then u squared would be my outer part, the derivative of the inside would be f prime. The derivative of the outside would be 2u. So this derivative would be 2u, which is 2f, times f prime. And we're looking at it when c is 2. So this is 2 times f of 2, which is 4, times f prime of 2, which is negative 1. So that comes out to be negative 8. And remember, with chain rule, if doing it in your head is hard, if you set it up with a u, that's going to make it a lot easier. So this one's very similar, except we don't have the u squared, right? We have f of g. So the inner part here is g, the outer part here is f of u, and then the derivative of each of those would be g prime, and then f prime of u. So this is going to be f prime of u, which is g of x, times g prime of x. And so calculating that, g of 6 is 4. So I'm going to do f prime of 4 times g prime of 6. F prime of 4 is negative 1. And g prime of 6 is negative 2. So this just comes out to be 3. Now let's do some where we actually need to use some of our rules. And I would remind you guys that you are not going to always be asked for the hardest rules, right? There might be one where you have a product in a quotient or a chain in a product or something like that. But that's not going to be the norm for what's on the test. So we're going to look at some simple ones, and then we will go from there. So for the first part, I look at this, I see either power, product, quotient, or chain for the big structure. This is just power rule. So I'm just going to take the derivative of each part. So the derivative of 4x to the 5th, the 4 is just a coefficient, bring down the 5, so that would be 20x to the 4th. And then same thing here, 5 is a coefficient, bring down the 4, so minus 20x to the 3rd. The next one is a product, right? The big structure there is E times sine. So I'm going to do the first times the derivative of the second plus the second times the derivative of the first. For the next one, I see that as a chain rule because I see this inside x to the negative first. Some people might rewrite that as 1 over and then see it as a quotient rule. Both work, right? Neither is more correct than the other. But if I do this as a chain rule, u would be x to the 4th plus 3x. And then this would be u to the negative first. So the derivative of that is negative u to the negative second. Derivative of this is 4x cubed plus 3. And so if I multiply those together, this could also be negative 1 over u squared. This would be negative 1 over u, which was this, squared, times 4x cubed plus 3. And you can't do much simplifying there other than just multiplying across the top and making that negative times 4x cubed minus 3. Now, let's look at this one here. So looking at this, I can't simplify right there. The best I can do is I can say, okay, this is a quotient. So I'm going to use quotient rule. So low d high minus high d low all over low squared. And then I can simplify that. So distribute out the 1, that would just be 1 plus x squared. This is minus 2x squared, so that would be negative x squared plus 1 over 1 plus x squared squared. And that does not simplify, so that's your derivative. Now, if I look at one like this, which looks very similar, the difference here is I could divide each of these by x, because I just have a monomial in the denominator. And so that's the same as x minus x to the negative first. And that's a derivative I can take with power rule. So it saves me a lot of work in simplifying to do that. So the derivative of x is 1. The derivative of that would be positive x to the negative second. So that's 1 plus 1 over x squared. Same thing with this one. I see here that I could multiply these before I take the derivative. So same basis, so I can add the exponents. And then from there, this would be 15 over 2 x to the negative 3 over 2. And you can move that down to your denominator. So 15 over 2 x to the 3 halves. So let's look at one where maybe there's a little bit more involved. So if I look at one like this, look at the big structure first. Before you go and look at anything else, look at what is your big structure here. Overall, this structure is a product. Now, within that product, I see that maybe I need chain rule, but overall, that is a product. So I'm going to do the first and the second. So I'm going to do the derivative of the first, leave the second alone, plus this first times the derivative of the second. And I see that that involves chain rule. Now you can do that off to the side, or you could say, okay, the outer part is the 7, so it would be x cubed plus 1 to the 6th, and then multiply by the derivative of the inside, which would be 3x squared. And again, use a u if you need to. U equals x cubed plus 1. Then this would be u to the 7th, and you could take the derivative that way. So let's do one more. Let's do an implicit. And then if you guys have other questions, send them to me. So this first one, I've got xy plus y squared plus x cubed equals 7. I can't get y alone there, so I'm going to have to use implicit differentiation. So that means whenever I have a y and I take the derivative of it, I'm going to put a dy dx after. So this is going to be a product. So the first times the derivative of the second plus the second times the derivative of the first, plus the derivative of y squared is 2y, but multiply by dy dx. The derivative of x cubed is 3x squared equals the derivative of 7, which is 0. Now I see here that both of these terms have a dy dx, so I'm going to leave those on the left side. These two terms I'm going to move over to the right side. So x dy dx plus 2y dy dx equals y, negative y, because I subtract that over, minus 3x squared. I can factor out a dy dx. Negative y minus 3x squared. And that gives me dy dx equals negative y minus 3x squared all over x plus 2y. And guys, those are the big ideas. I would say, again, like expect maybe one that's a little bit tougher, but don't expect that to be the whole test. And make sure you understand that derivative is slope, and you can do limit definition and your regular rules. If you have other questions as you're studying, shoot them to me. But overall, I would say that's a pretty good overview. The review sheet key is on Canvas. Just go into the OneNote. And again, if you have questions, just let me know.